Simple electric circuits are an important concept as they have practical applications in our everyday lives. This model highlights the scientific concepts of current, voltage, and resistance, all crucial elements in relating to the concept of electricity and electrical circuits. Cells and batteries are one of the most important inventions as they make everyday tasks a lot simpler. However, batteries and cells are quite different from one another. A chemical cell is a device that stores and converts chemical energy into electrical energy. They provide a much shorter power supply and light up items that require lower energy power, such as a clock or a lamp. When two or more chemical cells are connected together, they form a battery. A battery is a collection of electrochemical cells that either connect in series or in parallel. They're a lot heavier and they last a lot longer. All batteries are made up of three components: an anode, a cathode, and some type of electrolyte. The anode permits electrons to move out of it, creating a steady supply of electrons that move from one place to another until it returns to the cathode. Due to the chemical reaction within the battery, the anode builds up an excess of electrons, causing the electrical difference between the anode and the cathode. The electrolytes ensure that these electrons do not carry straight to the cathode. If a circuit is added, it enables the electrons to move out of the anode and make its way forward to the cathode in a smooth and steady flow. When electrons move through a circuit, we call this an electric current. However, currents and electrons flow in the opposite direction. A positive charge flows from the positive terminal to the negative terminal, whereas electrons flow from the negative to the positive. Electric current provides power to any appliance along the way, for example, allowing a robot to move, light up, or beep. However, in order to make electrons move around the circuit purposefully and in the same direction, we need voltage. Voltage, measured in watts, is a pushing force of free electrons in a circuit. Voltage moves the charge from one point to another in either a forward or reverse direction, creating a current. The higher the voltage, the more power and pressure there is, which means that the greater the pushing force of the electrons through the circuit. This will result, for example, in a brighter light. Lastly, resistors affect the flow of electrons within a circuit. For example, the thicker the wire, the lower the resistance. The longer the wire, the higher the resistance. Electrical circuits are especially designed resistors to purposefully restrict the flow of electrons. This could be for the purpose of protecting the components within the circuit from too many electrons flowing through it. For example, ensuring a light bulb doesn't pop, which will cause the circuit to short or break.